My name is Chiang Juay, and I look after all the undergraduate programs at the College of Design and Engineering, or CDE for short, at NUS. So I'm trained as a mechanical engineer, and I specialize in fluid mechanics, right? I look at aerodynamics, the design of the shapes of road vehicles, aircraft, so that they are as streamlined as possible to reduce the amount of air resistance. I also look at aircraft engines, trying to improve their performance so that they burn less fuel, so that there's less carbon footprint, right? So I'd like to first tell you what is design and what is engineering. So the word design comes from the Latin word designare, meaning to devise, to scheme, or to plan, right? In other words, you come up, right, with a plan in order to achieve something. And engineering also comes from another Latin word, ingenere, which means to create, to generate. And the key word here is cleverness, right? Is to come up with an idea that is clever, that's ingenious, right? So design and engineering, right, comes together, in which you try to create things, create stuff which are both useful and beautiful. So the designers will always aspire to come up with something that's aesthetically pleasing, that looks good to the eye. The engineer will try to come up with something that's functional, that's useful, right? So if you have designers and engineers coming together, putting their heads together to come up, to invent things, they'll come up with things which are both beautiful and useful. So let me give you an example, right? I'm sure most of us down here know that this is the rain vortex at the Juay in Chiang Airport, right? So this serves as our gateway, right, to many of the tourists that visit Singapore. It is also a good recreational place for many of our Singaporeans. So if you look at this Juay itself, right, it's an engineering and design marvel, right? So you have the architects that design the facades, right? You have the civil engineers that design the structural components so that everything stands together. You have the engineers, the mechanical engineers, right, that come together to bring about the water delivery systems, the electrical engineers for all the different electrical components, the lightings. You even have the landscape architects, right, that come together, right, to select the proper type of vegetation, plants, right, that will thrive in this sort of environment. And you also have the trains which are moving around, so you need the civil engineers, right, the transportation engineers to design that sort of thing. So again, this sort of marvel, right, is only achievable if both the designers and the engineers come together and they work together to end up with something that is useful and beautiful. Next, let me explain to you how design and engineering have evolved over the years. So in the past, the knowledge of design and engineers resided in the heads and the minds of some professors, and these professors will write textbooks, and students will come to universities to learn from these professors, learn from these textbooks. And when the students pass the exams, they have the knowledge, they go for interviews, right? And then they get hired, employed, and they work in a company till the day we retire. And in the past, knowledge is not so easily available. But nowadays, knowledge is very, very easily available. Knowledge is cheap, right? You can just do Google, Wikipedia, ChatGPT, and the knowledge is very readily available, right? So how do you make use, right, of all the knowledge that you have, right, in order to create or design something that is useful? So when you go for interviews now, the boss will immediately ask you, oh, are you able to design this app? Are you able to design this gadget? If you can start immediately on Monday, right? So what we can actually value add is the creativity, is to create the knowledge. And Singapore, as everyone knows, is a knowledge-based economy. So we need to create that knowledge, and associated with that knowledge comes the value that we can add. So based on this, we actually have devised a curriculum that has three important attributes, right? So the first important attribute is future-focused curriculum. And the purpose of that is actually to future-proof our students so that they are future-ready, right? So that they are able to tackle a wide range of complex design and engineering problems of the next decade, right? So we want to train them in skills which are important like sustainability, AI, digitalization, right? So that they are able to contribute to the economy. And the second aspect or attribute, right, is practical hands-on learning. Learning doesn't just stop within the classroom, right? We give our students a lot of opportunities to work outside the classroom. We have internships. We have a lot of projects which are sponsored by the industry, by companies. So students have the opportunity to apply what they have learned in the classroom in these projects, as well as to work together with people from different disciplines, right, in multidisciplinary teams. And a lot of our things are not just taught within the classroom setting, right? So a lot of our courses now are taught in a very hands-on manner where students, actually there's a lot of experiential learning. We get their hands dirty, right? So they have access to the 3D printers, right, in order to do prototyping, right? So the third and very important aspect is unparalleled choice and flexibility. And there are two important attributes to this. The first attribute is that our curriculum is now structured such that our students are able to take a wide range of electives, right? So because of the different electives that they take, right, they are able to distinguish themselves from each other. And the other aspect of it is that the flexibility also allows our students to explore a wide range of opportunities outside the classroom. They can go to different countries for their student exchange program. They can actually go overseas for an internship under the NOC program. Okay, next, let me tell you something about our curriculum. I like to think of this as a meal. Our common curriculum is just like our starters or appetizers, and it consists of 10 courses or 10 pillars. And the purpose of these 10 pillars, 10 courses, is to equip our students, right, with the set of skills. It's just like a toolbox, giving them more tools so that they are able to function effectively when they go out to work in a wide range of different career options or opportunities, right? So in this set of 10 courses, we teach our students 21st century competencies such as AI, sustainability, and things like that. We also have things like data and digital literacy, computational thinking. We teach our students how to do programming, digitalization, right? We also equip them with skills pertaining to project management, right? There's also makerspace where our students have the opportunity to do a lot of prototyping using 3D printers. We also inculcate in them the design thinking way of doing things, right? And we also emphasize on communication skills, both oral and written. So that is the set of 10 courses that we actually have all our students from CDE taking. And after the appetizer or the starter, which is the common curriculum, comes the main course, the main meat, which is the primary major, which nominally consists of 20 courses. And you have actually 15 different primary majors to choose from. So here is arranged in alphabetical order. But how I like to look at it is to actually mix it around a bit, then shake it and arrange it in terms of the scale of things. So engineering comes from very large scale, magnificent structures, things like bridges, roads. These are built by the civil engineers, right? Then you have these environmental structures, right? That is actually taken care of by environmental and sustainability engineering as well as landscape architecture, right? And then you have these built environment buildings. So architecture, they design the facades. The civil engineers will design the structural components, and the infrastructure and project management team will look after the project management aspects, right? And on the other end of the spectrum, you have very, very small things, at the molecular level, at the atomic level. So you have different atoms, molecules, piece them together, right, to give you functional materials. So that comes under material science and engineering, under chemical engineering. And in between these very large to very small, right, you have things that come in between, right? You have systems that move, right? So that is actually mechanical engineering. They look at things that move, how to convert energy from one form to another. There's also the engineering science program. And to look at electrical systems, right? Electronics, electrical power generation, communications, that is actually electrical engineering. And then if you like to look at software and hardware aspects of computer systems, that is computer engineering. And then if you like to look at supply chain management and things like that, that is industrial and systems engineering. And then in order to design things that look aesthetically pleasing, that comes under industrial design. So you see, we actually have a whole wide range of different majors for you all to choose from. And of particular importance, right, is the last one, robotics and machine intelligence. That is something new, fresh out of the oven, right? This is the newest degree program that we are going to launch for the next academic year, right? So in the good old days, right, if you have a robot, what the robot does is that it just does the same task, the same job again and again repeatedly. It doesn't complain, it doesn't take MC, it doesn't fall sick, so it does the same thing repeatedly. But now we have AI, we have machine intelligence, we have machine learning. So the goal is actually, right, to integrate, to synthesize the software and hardware aspects of robotics together with artificial intelligence, machine learning, right? And to piece together these things so that you have a robotic system that's not only able to do tasks repetitively, but are also able to think, able to adapt to the surrounding environment, and able to plan, able to navigate, able to exhibit human-like sort of behavior, like vision, machine, computer vision, speech recognition, right? So we would like to train or prepare the next generation of robotic engineers, right, in this area of robotics and machine intelligence, so that these engineers, when they graduate, they are able to go out and contribute in all the different industries like healthcare, the construction industry, and so on and so forth, where robots, right, are playing a greater and greater role in our everyday lives, right? So again, it's coming out of systems that are intelligent, they are able to think, they are able to react, able to adapt. So this is our newest degree program. Now, finally, after the main course, we have the dessert. So the dessert is made up of 10 courses, right? So the final set of 10 courses, right, will make up the unrestricted electives. So that's 10 out of 40 courses, which is effectively like 1 year of your studies here at NUS. So that 1 year, equivalent 1 year of studies, you spend it on electives. So these electives need not be taken in CDE. They can be taken outside of CDE, and you can have a choice of 100 plus different courses, second majors, minors, specializations to choose from, right? So this dessert itself is overwhelming, right? So just to show you how everything stacks up, right? So at the base, you have the starter or the appetizer. That is your common curriculum. So that lays the foundation for the entire structure, right? To prepare our students, right, with the common set of skills, 21st century competencies. Then after that comes the main course or the main meat, in which our students go deep into one of the 15 primary majors that they have selected. Then to top it up, the dessert is the electives, right? So within the electives itself, there's actually a lot of flexibility, right? So let me show you some examples down here. One possibility, if you want to go deeper into your own discipline, into your own primary major, you can take 2 specializations, right? If you are interested in another area of study which is outside of design and engineering, you can take a second major which is outside of CDE. Another possibility is to take a specialization and a minor. Or you can take 2 minors. Or you can take 1 minor and a basket of courses that you're interested in, right? So I've been talking about minors, second majors. So let me give you some examples of minors. So a minor is typically made up of 5 courses, right? So on this slide here, let me show you 7 different minors, right? So one of them is music. So if you want to face the music, you enjoy music, you can take that minor, typically 5 courses. If you're interested in Chinese culture, right, you can take a minor in Chinese studies or in the Chinese language. Well, that's not all. Well, let me add a couple more minors, right? So, well, you can see that there are many choices. So this dessert itself is overwhelming. There's so many different choices. The whole screen is becoming so cluttered up. There's something for everyone. So that's my message. There's really something for everyone to choose from for that minor, right? So in the second column, if you want to do a second major and a minor, is that possible? Do you have to pay more? The answer is no, because most of our minors and second majors, right, there are a lot of double counting with the courses that you may take with the primary major. So chances are that you don't even need to take more than 4 years to graduate, and you don't need to pay extra fees, right, if you take more courses. So this structure, the curriculum structure that you have, right, allows us to go deep and also allows us to go in the lateral direction, emphasizing on breadth, right? So we have both breadth and depth, right? Next, let me talk about a new minor or second major that we have in CDE. This is not a degree program, but it's a second major or minor. Now, if you look at this gadget down here, most of you may be too young to know what this thing is. It's actually a T-square, right? So most of the engineers, designers, they'll carry one of them together with them in their backpacks, and they'll use this together with a paper and pencil to make all sorts of engineering drawings and sketches. But nowadays, all these engineering drawings are done on a computer, right? So we do what we call CADing, right, using computer software. And nowadays, the computer software are very powerful. They are integrated with sophisticated software packages that allow you to do engineering calculations and simulations. So for example, you come up with an invention, you want to see using different materials, you want to see whether it will fall apart, right? You can actually do a structural analysis to see whether mechanically, structurally, the design that you have, is it going to fall apart? If this model that you have generates power, it's going to generate a lot of heat, so you can actually calculate the temperatures to see whether the temperatures are becoming too high and whether you need to do any sort of cooling or thermal management. So computing, digitalization skills are becoming of increasing importance for both designers and engineers. So together with our good friends at the School of Computing, SOC, we have co-developed a minor or second major in computing. And this by itself is not a degree program. It's just like one of the desserts that I was talking about. It's a dessert that you take along or you have together with your main course. So for example, your main course, your primary major can be industrial design. You can take, right, a minor in computing, right, within your UE space, the unrestricted elective space. You can also take civil engineering as your primary major together with a second major in computing. So you take the common curriculum courses in digital literacy and computer science together with machine learning. And this minor major, you have to take an additional few number of computer science and AI core courses. And there are a wide range of electives, specially tailored to CDE students from different majors. So you take those electives together with the core courses, right, to satisfy the requirements of the minor and the second major. And the purpose of this is actually to provide more context and more relevance of how computing can be integrated with your own primary major, so as to future-proof our students so that they are more ready, right, when they go out to work in terms of using these computing as well as digitalization tools. So another second major and minor that we have is a minor or second major in innovation and design, or IDP for short. So this gentleman here, he's Jeffrey Tiong. He graduated from our biomedical engineering department several years ago, and he formed and set up this company known as PetSnap, which is a household name now. It is NUS's first unicorn. It's worth more than $1 billion US, right? So he actually had this startup, right, and it was doing very well. So if you are interested in startups, entrepreneurships, technopreneurships, innovation, design, then this IDP second major or minor is for you. So on the screen down here, again, it's very cluttered. I have the logos, right, of many different companies, and these are startups by our CDE students. And I also wish to say every year, the number of startups, right, formed by our students is exactly like the number of companies that you see down here. And it's actually a lot, right? So those are for our students who are very interested, right, in technopreneurship, entrepreneurship, startups, right? Another initiative that we have, right, is a double degree program, right? So this double degree program is within CDE, and you might think to have 1 degree, you need 4 years. So to complete 2 degrees, do you require 8 years? The answer is no, because again, there are many courses, right, between our primary majors which are overlapping, and therefore there's some amount of double counting between the courses that you have. So this double degree program, right, you can actually take a CDE primary major and combine it with a second CDE primary major. So you end up with 2 different majors, 2 different degrees, and for most of the degree combinations, nominally you take 180 units within 4.5 years. So you are able to graduate mostly within 4.5 years, 4.5 years. And the good thing is that, do you pay extra? No, because the tuition fee that you pay is only for the primary degree program. All right, so this is our double degree. So you will end up with 2 separate degrees in 2 different CDE primary majors. Our students also go on to win many different awards, right? So they win awards at the national level, at the regional level, and at the international level. So if you start at the lower right-hand corner, right, you have this Recycle Right project, right? So it won a national award, right? So he actually came up with the different types of bins color-coded so that he can separate the different types of waste and rubbish and things like that. Then we have another Red Dot Award that's being given to this team, which came up with very nice features, right, in order to improve the quality of sleep, right, by improving the acoustic properties of the room, the lighting, as well as the aroma, right? And then on the upper left, right, we have another team that work on how do you improve the quality of the water coming out from the water cooler, how do you keep the things which are kept in the refrigerator fresher for a longer period of time, right? And most prominent is the one on our lower left, right? This team actually won the James Dyson Award. It is an international award, and they were the champion. They were the winner. So they have this HOPES. It's a home eye pressure e-skin sensor, right? That's the acronym for it. So it's basically a glove that incorporates both sensor technology and AI to measure the eye pressure, right? And the reading will then be sent to the clinician or to the doctor, right, to decide the type of medical treatment to give the patient. And again, our students are very successful at winning these awards, right, even at the international level. All right, learning occurs in the classroom, but we also encourage students to stay on campus, right, to experience campus living, right? So we have a number of different platforms or opportunities for students to stay on campus. So the first one that we have are the residential colleges. So these residential colleges are unique in the sense that the students not only live together, but they also learn together, right? Because in these residential colleges, they do mount some courses, right? And the students take these courses together. But don't worry, these are not additional courses. We have a good agreement with them. The courses that the students take in the residential colleges are part of our common curriculum and they count towards the graduation requirements. Now, hot out of the oven, one new residential college is Acacia Residential College, and it will have a focus on AI. Then apart from residential colleges, we have the student residences and halls of residence. These are the more traditional hostels, right, that we have in which students live together, and there are many different types of CCAs, activities, right, sports groups, cultural activities within the halls of residence. And the last one are houses. These are slightly smaller communities whereby students come together. There's a lot of peer support, creating a lot of very safe environment. Right now, we have 3 of them: Helix House, Pioneer, and Lighthouse, right? So we also hope that our students step out of the classroom. So learning doesn't stop within the classroom. So this is learning outside the classroom and to venture even further away, to go global, to go international. So we have many different types of international opportunities in store for our students. We have student exchange programs, right, with more than 300 partner universities in over 40 countries in different continents. We also have the NUS Overseas College, right, in as far away as Silicon Valley, in Europe, like Munich, Paris, Stockholm, and closer to us, we have in China, in Beijing, and in ASEAN, we have Malaysia, Thailand, Indonesia, Philippines, and Vietnam. And NUS Overseas College provides a platform and opportunity for our students to go overseas and do an internship at the startup and to take courses at some of the local universities, right? So it's a very good learning experience for our students. And we have other types of overseas experiences, such as overseas design immersion, study and field trips, as well as summer and winter programs, which are very, very popular. So having heard all this, you might be very excited and you might start thinking, oh yes, I want to apply to CDE. So how do I do so? Okay, so if you go to the portal, right, that is actually owned by the NUS Office of Admissions, or OAM, you go to the portal and you try to apply to CDE. Under the portal itself, you realize that for CDE itself, you can apply to 5 programs: architecture, computer engineering, engineering, industrial design, and finally, landscape architecture. Now, if you want to apply to, let's say, mechanical engineering, you realize that it's not listed there. Well, is there a problem? No, actually, it's not a problem. It's because engineering itself actually consolidates all 11, right, of our engineering programs, including mechanical engineering, electrical engineering, and what I mentioned just now, our newest one, robotics and machine intelligence. And all these 11 programs are classified under this engineering program category because they have a common set of requirements and they have a common set of standards, right, cutoffs for students to apply. So if you just choose one of the majors, let's say mechanical engineering, we guarantee your first choice. And there is also a major to be decided category. So if you're not sure, right, what exactly you want to do out of those 11, you can actually select the major to be decided. And that's very good for students who are going for national service. They will only come in 2 years later, so they are not too sure what exactly they want to do. Or even if you make a decision now, later on, you can still change your mind, right? Okay, so next you would ask, am I qualified to apply? Okay, so this tells you about the admission requirements, right? So just to focus on what's on the right column, 3 of our programs, architecture, industrial design, and landscape architecture, they require interviews. But don't be afraid. It's not like in the old days. The interviews are not like a one-to-one, you sit in front of someone being interrogated, right, by another person. So nowadays, the interviews are asking you to submit a portfolio, asking you to make a selfie of yourself. So it's more interactive in that sense, right? And then in terms, right, of the subjects that you need to have taken, right? This is for A levels, right? So you realize that the joining words, all of them have the word or. The only time and appears is for computer engineering, right? So for all the engineering programs, the 11 of them, you just require a pass in mathematics, right? For computer engineering, you need a pass in mathematics and physics as well, right? So for engineering and computer engineering, the mathematics need to be passed at the H2 level, whereas for architecture, industrial design, landscape architecture, the courses are either at H1 level or O-level passes, right? And then the admission criteria for students from IB, okay, so IB, they do SL and HL, right? So that actually corresponds to our H1 and H2 for the A levels, right? So for architecture, industrial design, and landscape architecture, right, MAI is sufficient. However, that's not sufficient for computer engineering and engineering. We do not accept MAI. We only accept MAA, all right? For NUS High School, the requirements are quite similar to those for A levels, right? For engineering, we need mathematics, and again, the joining word in all these are all except for computer engineering, which requires mathematics and physics or chemistry, right? And then for architecture, industrial design, and landscape is also mathematics or physics or chemistry and something else, right? Polytechnic diplomas for architecture, industrial design, and landscape architecture, we accept applications from all diplomas, whereas for engineering and computer engineering, we have accredited diplomas. I will not go through them in detail down here. A lot of them can be found on our website. So those are the relevant accredited diplomas that we have, that we accept, right? And for international students, again, there's a long list of them, and I strongly encourage you for those international students to visit this particular website down there to get more information. Then the next question that you ask is that, are my grades good enough to get in, right? I cannot exactly tell you or articulate what our exact cutoff is, right? But in this table down here, I've listed down what we call the IGP, or the indicative grade profile, right? So in the middle or second column, we have the 10th percentile. So how you should interpret this is that we accept 10% of the students with grades which are lower, right, than what's shown in the second column, right? So that will give you some indication on whether your grades are able to make it or not. But however, do bear in mind that grades are not everything, right? So for the students that do not really achieve these grades, indicative grades that we have listed down here, we do look at other things. We do conduct interviews, and we do look at other things like CCAs, any leadership positions, any special projects, right, they can show, right? So we look at the holistic, or we look at the student holistically to decide whether finally to admit them or not. But of course, the first step is to apply. If you don't apply at all, then of course you won't be able to get in, right? So next, I'd like to talk a bit about awards, scholarships. I believe there's another session that talks about scholarships, but here just let me emphasize on a relatively new award known as the CDE Masters Award that we have been giving out, right? So the rationale behind this is that we would like to form a long-term relationship alliance with our students, right? We want to future-proof our students to make sure that they are future-ready. So at the point of admission, for those very good students, provided you are local and you apply for one of our engineering common programs, right? We will award you a master's award so that after you finish your bachelor degree program, right? Let's say you choose to go out to work, you can actually embark on one of our MSc coursework programs. And listed down here, you can see there are many of them. And we'll pay, right, for your tuition in doing that MSc. So we have the obligation to pay. The obligation is not on you. And the purpose, again, is that we would like to cultivate, right, this long-term relationship with you and to attract you, to encourage you to move on, right, to do a master's. University education is not just about staying in the classroom, right? There are also lots of activities that we have to enhance, right, the learning experience of our students, to enhance student life. Okay, so on the campus itself, right, in order to create a more balance between study and recreation. So in order to enhance study-life balance, right, we have a lot of opportunities, right, for students. There are these places whereby the students can come together to grow crops, right, to bake cakes or make certain food. We have kitchens and all these things. So we have all these different types of environments for students to de-stress, right, to relax, right, for students to come together and mingle around. So life on university is not just on studying or academics, right? So the main message down here is that we would like to encourage, right, all our CD students to work hard, to study hard, but also to play hard and to live well, to balance studies together with other aspects of life. In other words, study-life balance. So with this, I'd like to strongly encourage you to consider starting your journey with us. So please consider applying to one of our 15-degree programs, right? And NUS is very highly ranked, right? On the QS ranking, right? We are ranked number 8 in the world, number 1 in Asia. So we will future-proof you, right? And we'll prepare you for your future careers and make sure that you are ready to tackle, right, all the 21st century challenges, complex engineering problems that we have. So to find out more about our other CDE programs, please scan this QR code, which will provide you with much more information. And I would like to thank you very much for your kind attention.